think we can get started, 12:31 already. Um, I'd like to get started today. I'm going to be talking about AsyncAPI and Springwolf, but I'd like to get started by giving a little bit of context of how we got to the actual scenario. And the first thing I'd like to talk about is this architecture, the three-tier application, right? This is probably the most universal architecture that you guys have seen out there. Probably the way you guys explain how a software, an application works for, let's say, your grandmother or friend or cousin who wants to become a software engineer as well. So we have, for example, the presentation layer, the application layer, and the data layer. Very simple thing. The thing with this kind of architecture is that usually when you're asked to make changes, we're asked to make business changes, right? And when we make changes in this kind of architecture, we're supposed to change all of the layers most of the times, right? So if you have to change something in the business, you're probably going to have to change something in the front end, something in the back end, and also maybe something in the database. But the question is, why do we organize our applications like that? So this is practically a universal architecture, but why is it universal, right? And what I'm saying right here is not only things that I came out of my mind, right? I'm actually paraphrasing Sam Newman in the book Building Microservices. And one of the things that he says is that the reason why we organize our applications like that could be because this is popular, so we've seen this before everywhere, so we're inclined to copy. Or it could also be because this is the way our organizations are structured. So our teams inside of our organizations are structured. And there is even a law to describe it, which is the Conway's law, right? So if you guys been working with software development for quite a while, or maybe even today, you probably have worked in companies where you had like a front-end team, a back-end team, a database team, DB admins, right? This is how most companies use it to organize their teams before. And one interesting thing is that last week I was watching this movie. It's called Big. Have you seen this movie? From 1988, starring Tom Hanks. And an interesting thing, there are two interesting things about this movie actually. The first one is that Tom Hanks, he's a kid, right? And in the beginning of the movie, he makes a wish that he will become big. And he becomes big, his life turns upside down, and well, he needs to find a job, and he finds a job as an IT consultant, right? And the first thing that happens is that he starts working, he's really fast, and his colleague, it's his first day, tells him, hey, you gotta slow down. Are you trying to get us all fired from here? This is the first thing. The second thing is that, well, he goes to the toy store, it's a toy company, he goes to the toy store, he meets the founder of the company there, they play together, and he's promoted into vice president of the company. And the guy who is the rival of him in the movie gets jealous and says, hey, how does he even get here? I mean, he was just an IT guy, right? So that's how traditionally we were seen inside of the company. Just the IT guy who is there, not very important, right? Like 20 years, 30 years ago. But these forces have changed. And aspiration around software development has changed. We want to ship software much faster than ever before, and we need to make it easier to make changes in our code base. So it means that software nowadays, technology nowadays, is in the center of the companies, is the heart of the companies. If you have banks, for example, traditional companies that have been there for a century, maybe 2 centuries, nowadays they rely on software as the center of their business. And their customers, not only banks but other applications as well, have had the software or their applications as the first point of contact with the company. But the thing is, before we were choosing cohesion of technology instead of business, right? And now these forces are changing us to choose cohesion of business functionality instead. So in order to do it, we also need to change how we group code, and this is forcing us to rethink the way our organizations are structured, which in turn is forcing us to group people by the way we break business apart. So if in the past we were breaking our application like that, so a presentation layer, an application layer, and a data layer, nowadays we decided to start breaking our application like this, multiple business lines, one next to the other. And by organizing our code like this, we can now have dedicated multidisciplinary teams working on each slice of our application. So we have a product catalog service, an order management service, a payment service, a shipping service, and a notification service in this case, right? And also these teams, they are autonomous enough to decide if they even want to have an application layer, a presentation layer, or a model layer. So it depends on the team. Maybe they say, okay, I need a relational database. I work better with the document database. Maybe I don't even need a database. But the most important thing about organizing our companies like that is that now when business asks for a change, so let's say I need a new notification to be sent when an order is made, this change is going to fall in one or two, maybe more teams, but not all of the teams, right? So only the ones that are responsible for this part of the business. However, there's still a problem, because our communication is still coupled. So we've been trying to decouple our teams, our business lines, but our communication was still coupled, right? So when you had a monolith, the services inside of the monolith, they would communicate with each other and they would block each other. But now that we have these services apart from each other, we want to avoid this blocking communication. And as you can see here, we have the order management team, notification team, send a notification for me. So when an order is created, the order management service needs to contact the notification service and say, hey, send a notification for me. So basically, it needs to have knowledge about the notification service and how it works, right? But we want to change this paradigm as well, or shift this way of communication as well, and you want to move towards non-blocking communication. So instead, we want our order management service just to say, hey, an order has been created, and the other services, those that are interested in it, to react accordingly, right? So you have the notification team now saying, hey, that's my queue. I see that an order has been created. I'm going to send a notification. And this is today the leading software architecture in microservices, right? So we're talking about event-driven communication, event-driven architecture. Who has worked with event-driven architecture before? Like, nice, all of you. So just a recap, almost all of you. So an event is a factual statement about something that has happened in your service. Other microservices can listen to the events they are interested and react accordingly if they're interested in them. The microservices that listen to the event do not need to be reachable at the time the event is emitted, so our communication is decoupled now. And the microservice that is emitting the event doesn't need to know anything about the microservices that are listening to the events, decoupling the communications between microservices. And the distribution of responsibility we see in our event-driven interactions can mirror the distribution of responsibility we see in our organizations trying to create more autonomous teams. So that's what we're leaning towards too. We're trying to create more independent and autonomous teams inside of our organizations so we can move faster and we can ship software faster. Okay, a quick recap of this context, right? So our software architecture is usually driven by the way we organize our teams. We need to release faster than ever before, and this has forced us to reorganize our teams in our software architecture. And this force moved us to more decoupled teams, architecture, and communication. So we move towards microservices with communication driven by events. And this is kind of the actual scenario, right? However, even though the goal is that we can change our software freely, so we have parts of our software that we can change independent of other teams, parts of our service is still coupled to other services, right? So we still have contracts, we still have events, and if we change those events, we also need to communicate the other teams that these events have been changed so they can change accordingly because we're going to affect them. And that has led us to AsyncAPI. Has anybody worked with AsyncAPI? Just a few hands. Had people heard of it before? Nice. Are you here because you're curious? Okay, cool. Are you here because you're just hanging around? Nice. I'm very honored, I must say, because you know that Josh Long is speaking in the next room, right? And you guys are here, so I'm very honored that you're all here. Thank you so much. But before I continue, I'd like to make an analogy, right? Because I'd like to talk about my mom, actually. You see, I lived with my mom for 18 years of my life in the same house. And we used to talk every day, and it was a blocking communication, right? So she was in another room, or maybe she was in the same room. She would ask something, we would talk about something, and we would wait for each other's response. But I moved out of the house when I was 18. I moved to another country later on, and now our communication is most of the time asynchronous. We send messages to each other, right? On WhatsApp, iMessage, things like that. And the thing is, being the son of my mother for 29 years now, right? And for my dad as well. And I've been married for a couple of years already. And with all of these people who I almost live every day together, I still have issues of communication. And then how can we expect that if we have issues of communication with our family, our spouses, how can we expect that our communication with our colleagues at work is going to be perfect? People who we have been working with for 1 year, 5 years, something like that, right? So we need better communication. That's why AsyncAPI is here. So AsyncAPI was started by this guy, Fran Mendes. He's Spanish. There's a lot of content about him online as well, podcasts. That's how I learned more about him. He created AsyncAPI back in 2006 when he was working at Hitch. And one of the things that he says in his podcast is that he was suffering from a problem, and many other people were suffering from the same problem he found out later on, right? He even gives an example that he was working at a company where they had so many topics in their Kafka broker that they couldn't even understand why those topics were there anymore. So people would ask, hey, how is this topic being used? Who is using this topic? They would check the consumer groups, for example. They would say that the consumers were like test 1, test 2. Nobody knew why these topics were there. There were topics with duplicate data, and he wanted to avoid these kind of problems happening, right? Besides that, he also wanted to make it open source. He got several proposals to get it bought, but he declined because he wanted it to be open source. He wanted it to be like the OpenAPI of the async APIs. But in a nutshell, it's a communication contract between senders and receivers. And well, how does it work? First of all, we start by defining a file. So it can be a YAML file or JSON file. So we start by defining the version of AsyncAPI. Right now it's 3.0. A lot of breaking changes were introduced in this version. Then we have 5 root elements: info, servers, channels, operations, and components. And I'm going to be creating the file with you right now. So the first one is the information, right? So you have information from our system. The information have all these elements to play with. So you have title, version, description, you name it. So here, for example, we have an API called Pegasus. The version of this API is 1.0.0. The description is that this API provides information about bookings. We have a contact. It's the Ego team. Let's hope that the teams are not restructured and next year somebody tries to find the Ego team, it doesn't exist anymore. Right? You have some tags. So this is the Pegasus system, and you have external docs leading to some docs with outdated documentation. That's usually how it happens in our companies, right? Then we have servers. So the servers are the servers that our API will be communicating with. It could be like, as I put here, the production server, the staging server, 2 Kafka brokers. We could have 2 different production servers. You could be reading from a RabbitMQ and publishing to a Google Pub Sub, for example. It all depends on your own implementation. This is a specification, right? So you're free to play with according to your needs. So we have 2 servers. You can see that they have the description, host, protocol. The first one is Kafka secure. So the first one has security. They have tags. The second one doesn't have security. After that, we can define our channels. So I defined 3 channels here. So the channels, they also have address, title, description, messages. So the first channel is the flight bookings. So you have the address of the channel in your broker. Could be your Kafka broker, RabbitMQ broker. You have the title of the channel, the description as well. The servers it interacts with. So you could have some channels that interact with one server but not with the other, especially if you're dealing with multiple servers in production. And then you have the messages that can be produced or read from this channel. And the same thing for the second channel, the passenger check-ins. Now that we define our channels, we can think about our operations. And in AsyncAPI 3.0, they added a breaking change. So they changed the action, as you see there. So you see that our operation is actually telling us how we can use our channels. So we can read from our channels, we can send messages, or we can receive messages from our channels. And this is application-centric, so we're looking at it from the perspective of the application, right? So if you look at the first one, for example, send booking confirmation, the action is send. So it means that this API is sending messages to booking confirmation topic. And if you look at the last one, receive passenger checking, you see that the action is receive, so it means that our application is receiving messages from this topic. But then you also define other details, the title, summary, description, again, the channel that this operation is working on, and the messages. After that, we have components. Components can be almost everything that you can define inside of your AsyncAPI file, and it's everything that is reusable, right? So you could define a message, for example, that is reusable across your AsyncAPI file. We will define it here and then reference it elsewhere. After we define and for example, a type of component is schemas, right? So these are the payloads that could be of your messages. So you have two examples here. The first one is the booking confirmed. Two Afro schemas in this case. They didn't have to be Afro, but in this case they are. They're already defined here. And the third one is right here, so the passenger checked in as well. And with these schemas, we can then create our messages that are referenced in these schemas, as you can see there. So we have 3 messages again, and the schema could be right there, but the good practice is to make it reusable, so if another message is also going to use this schema, you can have it defined elsewhere as well. So the message, it has a name, a title, summary, and the payload. This is also a breaking feature that was, not a breaking, a new feature actually, that was introduced into AsyncAPI 3.0, and it's about the reply request pattern. So this pattern is basically when you receive a message, you read a message from one topic, and then you publish a response, let's say, into another topic. Right? So they also added a way that you can specify in the operation that you're going to be receiving a message from this topic, but then a response is going to be produced to this other topic, and could even be dynamic, so you could receive the message, the topic where it's supposed to be published as a header from the message that you received, for example, and it's also supported by AsyncAPI. But let's get done with talking, and let me show you AsyncAPI Studio now. Because if you get all of this information that I showed you and put it on AsyncAPI Studio, so studio.asyncapi.com, it's offered by them. So I just pasted all of this information here, and it came up with this beautiful UI here with all the information that I can share with my colleagues at my company, or even for future reference or onboarding or anything else. So you can see that we have the information about the system, the external docs, the servers, and finally the operations, the channel that it acts on, if it's a send operation, if it's a receive operation. I have the payload of the message as well, and also the messages here in the end, and the schemas. All right, but AsyncAPI is not just about this specification, it's about tooling as well. So they also offer parsers and other tools that you can use to build your own applications or validators or document generators or anything else. And one of these generators is actually, oh, sorry, forgot to come back. Springwolf. So Springwolf is analogous to SpringFox, right? So you have AsyncAPI as OpenAPI and Springwolf as SpringFox. And I don't know much about the history of Springwolf. What I know about it is that it was created in 2018 by the first guy here, Stav Shamir. And it's inspired by SpringFox, has been downloaded more than 500,000 times. It's compatible with Spring Kafka and Spring Cloud Stream. It gets monthly releases, and it has a strong and open community. So I know that these 3 guys, rather than Stav Shamir, also him, are the ones that are contributing the most nowadays. They're very open. I talked to Timon Back, for example. I asked for, I opened some issues in their project as well, and they quickly answered and implemented the issues as well. So they have a strong and open community, right? But what does it actually do? So first of all, it automates the documentation generation, right? It's boring to define your async API file by hand. So how it would be better if we could just generate it automatically. So you can see that it's done by scanning relevant annotations in our application, such as Kafka Listener, Rabbit Listener, SQS Listener, or even their custom annotations as well as the async listeners. Then it extracts information from this, from your code, and builds the async API file for you, right? So it means that it's async API compliant. So it adheres to the async API specification. It uses their standard structure and format, and also improves the understanding of your application. But the two things that I like the most about Springwolf are the ones that I'm going to talk about right now. The first one is the interactive web UI. So they also offer a web UI that you can spin up right from your Spring Boot application. That has easy navigation. You can explore everything just as I showed you in the AsyncAPI Studio as well, and also enhances understanding. And finally, I think this is the one, this is the feature that I like the most actually, that is message publishing right from the web UI. So instead of going to AKHU, for example, or your RabbitMQ manager, you can just, right from the UI, send messages directly into your application with the examples that are generated automatically for you. So I've already talked about some of the benefits, but yes, it reduces manual effort, it improves collaboration, fast onboarding in your company, and enhances testing, and makes developers happier by being able to understand their software better, and also to test the software easier. How does it do it? This is basically repetition of what I had already said. And finally, let's take a look at the code. So in order to get started with Springwolf, the first thing you got to do is add these implementations in your Gradle file or Maven file. So the first one is the plugin. Here I'm using Springwolf Kafka, but you could have been using RabbitMQ or CloudStream or another one. And then I also have the Springwolf UI that I want to use to see my documentation and interact with my application as well. So if I open now my application.yaml, you can also see, let me zoom in a little bit. Can you see it? Is it good? Okay. So you can see that this information that is static, the information from your API and the servers, you also define it here. So it's not picked up from your application automatically, because there's no way of doing it. But besides that, you also configure the message publisher from the UI right here. So you can see that you can define the serializer. I'm using the Avro serializer here, and also the schema registry right here. So after I've done it, I created some Avro files representing our schemas. So we have booking canceled, booking confirmed, and passenger checked in. And then I created a listener here, very simple one, just to exemplify. So we have this annotation here, Kafka listener. What Springwolf will do is he's going to scan our code, he's going to find this annotation, and then he's going to create the API, sorry, the async API file automatically from there. But not only that, we also have the publishers. And for the publishers, since we don't have an annotation that I need to add for it to work, we need to use Springwolf custom annotations here. So you annotate it with async publisher, and then you define the details of your operations inside of it. So you can see here that have the channel confirmed bookings, the description, the servers that it interacts with, and also the same thing for the send booking canceled here. Another thing that you could do is also enhance the details of this listener by adding the async listener annotation here as well. So let me run this application. Sorry, there's one more thing. So you can see that I added these two files into this exposed package, because for the sake of this example, I also added these two listeners so you can test, and you can see that our messages are actually being published. But I didn't want them to show up in the AsyncAPI file. So what I did was, the ones that I wanted to be exposed, I added to this into this package, and I told AsyncAPI to only look into this package as the base package. So if I run my application right now, and it works, and go back to our browser and open our documentation. So I came into springwolf/AsyncAPI-UI.html. This is what you're going to see. Let me close this one. So you see that we have the information of our API. We have our servers, the servers that the API interacts with, and the channels where the API operates, right? So I have basically the same three channels. So this one, the API will be receiving from this channel and sending to these other two. We also have the schemas here. But the features that I like the most here are this one. So we have already a message generated automatically for you, an example. Maybe you cannot see from, yeah. And also, you can publish it directly into your application right from here. So if you come back, you see that the messenger was created in our system here. But not only that, also, if I come back, and I can also download the AsyncAPI file from here. I can download it either in JSON or YAML. And if I copy it and put it on AsyncAPI Studio, I should also be able to see it here. And you can also see that I have the servers, the channels, the operations, the messages, and the schemas. That's how Springwolf works. And then you may ask, okay, what's next? And the thing is, they have a strong and very open community, right? People are contributing. I think this is a nice project for you to start contributing as well. But first, I'd like to invite you all to try it out. So you can check springwolf.dev, and you'll fall into this website. They have a demo, just like the one that I showed you here, that you can play with, and also how you can easily get started with it. But also, it's a nice project to contribute if you guys are into open source, or even using your company, because every issue that I open, so for example, they didn't support Avro files before, Avro schemas before December, but then I asked them to. I opened the issue, I tried to help them with that and investigate. And in January, it was already there, released, so they're releasing every month. And recently, we started working with topic patterns in our Kafka listener. It was also not supported, but after I talked to them on their Discord server, they also released a new version by the end of April that is now supporting topic patterns in Kafka listeners. So that's what I have about Springwolf. Now a little presentation about me. My name is Raphael. I'm a software consultant at Xebia in the Netherlands. I'm also a knowledge sharer. I have a YouTube page, a Medium page. I'm also part of Spring Builders, the new Spring community where people are sharing knowledge as well. And I'm also the Kotlin Dutch user group organizer back in Amsterdam. And that's it. Thank you very much for listening. Okay, it was much faster than I expected. 30 minutes only. Nice. Do you have any questions? Yes?
Yeah, so another way that people use the OpenAPI specifications is also to generate the Spring code from the specification, like
yes.
Not the other way around. Is there a library like that for AsyncAPI as well?
Yes, there is. There is a generator for Spring files, actually, but I saw it yesterday. It's still on version 2.6, so AsyncAPI version 2.6.0. And from what I've seen, it hasn't been updated for 5 months now. But there are, and maybe it's also an opportunity to start contributing to this project as well. Thank you. Questions? Yeah.
Thanks for the talk. I was wondering two things. One was the question who uses this topic, which was like kicking off the AsyncAPI thing. The question of responsibility is still you need to write it in the application properties. So this team uses or provides this endpoint. So it's not really automatic in a way, is it?
So if you look at the code, for the publishers, it's not completely automated, but for the listeners, it is, because for the listener, all you need is the annotation that you already need to make a Kafka listener, and Springwolf will just detect it and generate the documentation for you. But for the publisher, since we don't have annotations here that are required by Kafka, by Spring Kafka to work, then we indeed need to add the async publisher annotation that is provided by Springwolf to get the documentation generated for you.
Okay, cool.
Yeah.
Second question.
Sorry, it's just one more thing, but the message will be automatically detected from the method signature. Yeah, and also the channel is provided here, sorry.
Okay, thanks. Second question is about web UI and listeners. Is it possible to listen to messages, like using this kind of connection?
No,
okay.
No, just publish.
Yeah, okay, thanks.
But maybe you can add this feature. I think the UI needs a ramp up, actually. So.
Regarding a Spring Cloud Stream, does it work? You don't necessarily have those annotations like Kafka Listener.
Yeah.
Have multiple types of.
I have tried with. I haven't tried with Cloud Streams, but they have support to it, and I believe them that it works. But in their website as well, I think the demo also shows it. They also have examples in their repository. If I open springwolf.dev and go to the demo, I have many examples here, and also I thought we had the one from CloudStream. Maybe there is, but yeah, but it's not showing up here. But in the repository, there are the examples that you can check how it works.
Thanks.
Sorry, can you repeat?
Thanks for the talk. My question is, it's not the OpenAPI, the API first idea. I mean, you write the specification and generate the code.
Yes, by using Springwolf, that's the idea. If we start with AsyncAPI, those generators that I said before, then it could be API first.
Okay.
But from my use case, I prefer to go this way, so that's why I wanted to talk about Springwolf. Yeah.
But it's possible to create?
Yes, it's also possible. But as I said, the project, from what I've seen, hasn't been updated in 5 months. No. So we better check it out before we start using it this way.
Okay.
Thank you.
I wasn't aware of this project, and I'm seeing a lot of great potential to it, so thanks for the presentation. My question is, how does it deal with things like deprecation and version and schema evolution? Like, how does it convey information that this field won't be available 1 year from now, or things like that?
That's a good question. I don't have an answer for that yet. I haven't got to this part of my project yet where you have to deal with it. So
it's still a good answer. Thank you.
Yeah, thank you. No more questions? Okay.
Yeah, so at our company we use Swagger Hub to collect all the OpenAPI definitions into like one central hub. And I just checked on the website and they said like there is now an AsyncAPI integration, so I got an answer to that question, but do you have any experience with it? Is it working well? Is it integrated well?
I don't have experience with it, but I saw in their website as well that they have integration with Backstage, so maybe something similar. Yeah. Okay. Thank you very much, everybody.